Welcome back to the final video of our point pattern analysis topic for Geography 300 Geographical Data Analysis. And here we are looking at what we were doing for presenting the results. In many ways, the principles from the previous approaches still apply, especially if you think about how many work with chi-squared. Well, the principles of applying chi-squareds and presenting chi-squared still apply here. Things like justify how you got your prediction. And things like the main thing I want to get is the results and particular sets of values instead of say everything that Excel may or may not give you. What is the p-value? What does it mean? Can, in this case, for a point pattern, can you take something like the variance to mean ratio and distinguish it's clustered or it's even versus being able to say it's not random and, well, that's all I know. The main new thing here, and likewise, as you would often present, here's my point pattern, you would map that out. Have good cartographic principles, good cartographic presentation as you would for something like local Moran's eye. As I said, a lot of the previous ideas still continue. What we're adding here is the recognition because, as I said at the end of, not the last video, but the one before that, there's no guarantee that these methods are all going to agree, especially if you have a non-random pattern. That means oftentimes we will be doing multiple techniques. So these one approach does not exist in isolation. So once we go, we say we might do the quadrant analysis with chi-squared and do Ripley's K. Okay, do they agree with each other? If they agree with each other, great. They agree. When we present and we say, look, I have done both of these tests. They agree. That makes me more confident. And when I am discussing the results, I will go and say, I am more confident in my results because I tested 2 or 3 different ways of analyzing my point pattern, and they all agree. On the other hand, what do we do if they don't agree? Okay, I might go and in my presentation, in my discussion, and say, I did an analysis with chi-squared, and say the variance to mean ratio, that said it was very heavily clustered. But Ripley's K might say, no, it might even say it's clustered, but only at a certain smaller distance, random for the most part. And we go and we can then kind of triangulate the different approaches and how they, so the distance-based versus the density-based, and say, well, here's the different approaches. What does the fact that, say, a density-based approach gave me one result, the distance-based approach gave me a different result. What do I do with that information? And especially for something like nearest neighbor, distance-based approach, it's only using the distance to that one nearest neighbor. It's ignoring most of the possible distances, pairs of points in the entire study area. So it's giving that limited perspective. As I draw on the board, that, at that one point, if I have evenly spaced clusters, Ripley's K might recognize that. Quadrats might recognize something like that. Nearest neighbor, it will just say they are clustered. So we can go and say, especially, okay, evenly spaced clustered. My nearest neighbor says it's clustered. Quadrats say they're evenly distributed because most of them have about the same number of points. Most of my cells, each cell containing one cluster, that's even. And we can use those different approaches and the different results to better understand why they might disagree and provide more information, more detail, more context for what sorts of processes might be going on. And the last thing is, which again, we won't necessarily be doing a whole lot in this course because everybody is coming with different background sets, different sets of background knowledge. But oftentimes, we will put this in the context of additional background knowledge that we have to help address equifinality and be able to make more of a statement, have a better understanding of what we can do with the results. So in terms of, as I said, the end point of any analysis is making some kind of decision, guiding policy, guiding some action. What then do I do with that information? Equifinality means most of the time I say it's clustered. Okay, I don't have a whole lot to work with there. But if I can say, if I am looking at a disease situation, it's clustered. And it's not just clustered because it's found in cities. It's clustered even more than I would expect from that. And I know, say that this happens to be something that is driven by a virus and something that is airborne transmission. That can then lead to particular assumptions about how infectious the disease is. And okay, there are things going on in some areas, like people gathering more than they should, leading to a higher density of cases in some areas than would be expected more broadly. Or I could take a different disease and say, okay, this is a pathogen again, a virus, bacteria, what have you, but it's something that lives in the water. Okay, and I see it is clustered around a particular stream. Okay, well maybe there's something with the sanitation of water feeding into that stream that is causing a problem. So I can bring in this extra background knowledge to use the information that the point patterns give us. Again, triangulate, combine this information into a more complete picture, and in the discussion present that more complete picture to the audience of that report, whoever the audience may be, whether that's the general public, whether that's a supervisor, what have you. So those are some of the ideas and things I'll be looking at. As I said, I'm not going to assume you have any background knowledge in the examples I choose for the point pattern lab. But for the most part, especially this sort of thing, of do they agree? Do they disagree? Why might they disagree? What does that tell you? Things I'll be looking for as I go and evaluate the writing portion of the point pattern lab. As always, if there are any questions, Please feel free to ask in Zoom classes, to reach out by email, and let me know what's confusing, especially, and I'll try to help you understand what's going on. So, again, thank you for watching. That has been a point pattern set of videos. And I'll see you at the next set. Have a good one.